A very good evening to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on kinematics of particles. It's a problem on rectilinear motion, type 4 problem on motion under gravity. That is, it's a problem using the kinematical equations, that is uniform acceleration motion. To find the height of the tower and velocity of the two stones when they reach the ground, when these two stones have been dropped from two different positions of the tower. Let us see the question statement. A stone is dropped from the top of a tower. Simultaneously, I'll be drawing the diagram. Just check. This is a tower that I can see. This is the ground position. From the top of the tower, first stone is thrown from over here. Over here it is dropped, so initial velocity u will be 0 and this is position number 1. Okay. Now when it reaches, it has fallen a distance of 10 meters from the top, that is at position number 2 it has fallen a distance of 10 meters. Over here the velocity, let me consider it as u1. Then at that time another stone is dropped from a point 38 meters below the top of the tower. From here at a distance of 38 meters, this I will be considering it as position number 3. Another stone is thrown from here. I will be considering at position number 3. Let this, it is dropped, initial velocity is u2 is equal to 0. Okay. If both these stones reach the ground at the same time, calculate the height of the tower and velocity of the stones when they reach the ground. Now what I can say is u2 is the initial velocity of the second stone. When it will be coming down, its final velocity with which it will be falling on the ground is v2. u1 is the initial velocity of the first stone. When it falls on the ground, let me consider its final velocity as nothing but this will be v1 of for first stone it will be v1, for second stone it will be v2. Now, and this position I will be considering as position number 4. Let this total height of the tower is equal to h. Let the entire height of the tower be small h. Okay. Now let us start. Given data. Now velocity of the first stone. Let u is equal to velocity of first stone. Velocity of first stone at position 1 is equal to u is equal to 0. Then I can write it as velocity of second stone when, that is at position number 3 from where it is dropped, is equal to u2 is equal to 0. That is fine, which is given to us. Now let us proceed ahead for motion of both these stones. Considering motion of both these stones, and let me write them. Motion of stone 1, and over here I will be writing motion of stone 2. Both these stones are performing motion under gravity. Since their motion is from upward to downward, I'll be considering the parameters in downward sense as positive. Now same way for this, motion under gravity in downward sense to be considered as positive. Now what do? I will be considering motion of stone 1 from position number 1 to 2. Here the initial velocity is 0. The final velocity is u1. S is equal to 10 meters. And A is equal to 9.81 meter per second square. Now out of the three equations, I just forgot to mention it. What are we supposed to find it in this problem? Let me just write it over here. To find, there is some space left out. To find is nothing but the height of the tower, h is equal to question mark, as well as the velocity of the stones when they reach the ground. That is, velocity of the first stone when it's reaching is v1, velocity of second stone when it reaches is v2 is equal to question mark. So now what do I do? One by one, let us now just proceed ahead. Okay, over here, apart from the three kinematical equations, which kinematical equation should I use so that I can get v? We will be definitely using v square is equal to u square plus 2as so that I can get u1. So using v square is equal to u square plus 2as. Therefore, v square is equal to 0 plus 2 into 9.81 into s is 10. So therefore, to be very specific, v is equal to square root of, I can directly write it down, 2 into 9.81 into 10, and the value of v is equal to u1 is equal to how much? Is nothing but 2 into 9.81 into 10. Square root of the answer is nothing but 14.007 meter per second. 14.007 meter per second vertically downwards. That is nothing but u1. Okay, that is nothing but motion of first stone. Now if I consider motion of the second stone from motion of the first stone, again going ahead, for motion of the first stone again, if I do consider it like this. Now if I consider from position number 2 to position number 4, again for the second stone as well, position number 3 to position number 4, let t be the time taken by both these stones for reaching the ground. So now from 2 to 4, here u is equal to u1 is equal to 14.007 meter per second. Of course, I am considering motion under gravity in downward sense as positive for both. Motion under gravity in downward sense as positive. Friends, why are we considering it now? Because the time required from 2 to 4 for the first stone and the time required from 3 to 4 for the second stone is the same, which is given in the question. Time required by both the stones to reach the ground is same. So let that time be t seconds. So t is equal to, I am writing it as t seconds. A is equal to 9.81 meter per second square. S is equal to, friends, to be very specific and very precise, just see the diagram for this, how much the distance would be from, if I say, just I will be moving it, if I consider from 2 to 4, the distance would be h minus 10 meters. I will be mentioning it over here. It is h minus of 10 meters. What about the third to fourth position? It is h minus 38 meters. H minus 38 meters. So you can see it very specifically, my dear friends, and this is the way that we are going to proceed ahead. Okay, now to be very specific, let us now write down S is equal to h minus 10 meter, that is for first stone. Using now to write down which formula to use specifically, I should write down the given data for 3 to 4 as well. Here u is equal to 0, t is equal to t seconds, a is equal to 9.81 meter per second square, and t is equal s is equal to h minus 38 meters. So here it is. As you can see, in both the cases the unknowns are h and t. Definitely we should use s is equal to ut plus half of at square. S is equal to ut plus half of at square. Therefore h minus 10 is equal to 14.007 into t plus half into 9.81 into t square. Okay, same way, using The same equation over here, S is equal to ut plus half at square, that is, it will be S is nothing but h minus 38 is equal to ut is nothing but 0 into t is 0. I will be writing plus half into 9.81 into t square Yes. So just check both the equations, dear friends, and let me know how do I solve it. You will be solving it simultaneously so that we will be getting a quadratic equation over here. Now h is equal to 14.007 plus 10, it will be, friends, 34, sorry, it is in terms of t, cannot be added directly. 14.007 t plus 4.905 t square plus 10, that is first equation. I can write it for h. Similarly over here, h is equal to 4.905 t square plus 38, that is equation number 2. If I write down equating 1 and 2, equating 1 and 2, equating 1 and 2, let me write them down over here. On the left hand side, right hand side doesn't matter. 14.007 plus 4.905 t square plus 10 is equal to 4.905 t square plus 38, and 4.905 t square, 4.90 t square gets cancels out. Then 14.007, it is in terms of t. Sorry, I forgot to write it over here. So 14.007 t is equal to 38 minus 10, that is 28. So the value is 28 divided by 14.007. So it is 1.999. Approximately it is 2 seconds. So I can write it, my dear friends. Therefore t is equal to 1.999 is equal to 2 seconds. So t is equal to 2 seconds. Let me just substitute that value of t in the equation number 2 using 3 in 2. Using 3 in 2, I can mention it, h is equal to 4.905 into 2 square plus 38. Therefore h is equal to 4.905 into 2 square plus 38. The value is 57.62 meters. 57.62 meters. Very interesting it is. Now we are not calculating the time directly. We will be even we have got the value of time, so we can proceed ahead to get the value of the final velocity. So how do we get that? Let us check. Now moving ahead for the same way. Now motion from 2 to 4 for the first stone, and motion from 3 to 4 for the second stone. If I consider over here u is equal to 14.007 meter per second, I will be mentioning it just mug in downward sense as positive. Even over here mug in downward sense as positive. Okay, t is equal to 2 seconds. So I can write it directly as v is equal to u plus at. A is equal to 9.81 meter per second square. What about this? Here the initial velocity is 0. T is equal to 2 seconds. A is equal to 9.81 meter per second square. So friends, using v is equal to u plus at, it will be v1 is equal to 14.007 plus a is how much, 9.81 into 2. Same way v2 is equal to u plus at, that is 0 plus u plus a into t, 9.81 into 2. So the values simultaneously that I'll be getting, V1 is equal to and V2 is equal to, the values are 14.007 plus 9.81 into 2, 33.627 meter per second in downward sense. Final value of V1 will be giving me 1 mark, yes, along with the direction. And same way 9.81 into 2 is nothing but 19.62 meter per second in vertically downward sense, which will be again giving me 1 mark. So 1 mark for this, 1 mark each for the calculations of this. So I can write it as 1 mark over here, 1 mark over here. And friends, since they have also asked us about the height of the tower, so 4 marks still here, and 1 mark for the height of the tower and 1 mark for calculating the time along with the calculations. So this is the way how the problem is getting solved. Please thank you for watching this video. Please do like, subscribe and share this video. Thank you.